All right. So, Mira, I forgot to record today's class. So, here's a quick lesson. So, the first thing was dilutions. What is a dilution? So, a dilution would be if we take a container that we'll call concentrated. So, say we have a concentrated container over here, and say it's magnesium nitrate, kind of like the magnesium nitrate we were talking about the other day. And let's say we're going to put it in this new container down here, make it bigger, and you'll see why in a second, right? And there's nothing in this container. We know in this magnesium nitrate, there's some stuff in there, and we're going to pour it into this container. So what are we pouring into it? Well, we're pouring something in milliliters, and we're actually pouring our moles in there too, because there's another container over here on the side, which I'll make red, right? And in this red container, it's just DI water. It's just plain old water. So it's DI water. And we're going to pour a certain amount in there. And there's no moles that are going in there. But eventually, we're going to get these two together in here. All right? So we're going to have a certain volume in milliliters or liters. And it's also going to have a certain big M as well. But that depends on how much of your concentrated solution you put in there. So let's say CONC for concentrated and DIL for dilution. And of course, this is our DI water, which is why it's diluted. So let's come up with some numbers, maybe even use some simple numbers and say, well, how about we say, let's pour 110 milliliters of a 1.2 moles per 1 liter, or big M. So it's a 1.2 big M solution. Let's pour it into there. And we're pouring 110. So we almost have the total here because we know it's 110. But let's say we pour water. Let's say we pour 50 milliliters of water. Again, no moles from that, but we now have a total. We now know we have 160 milliliters, and it's got the moles from this concentrate and no moles from this. So what is the new big M of this dilution if we knew how much we poured in and we knew the big M? Well, there's a fairly quick and easy calculation you can do, but a longer way of doing it would be, well, how many moles did we pour out from there? Well, we take our 110 milliliters and we multiply it by our 1.2 moles per 1,000 milliliters. So we actually know how many moles are going in there. So 110 times 1.2, then divide that by 1,000. So we know we're pouring in about 0.132 moles, which is good. All right, so we're pouring that many moles in here. So that's how many moles we have in here. But unfortunately, we now have a new volume of 160 because we've diluted it. So now we want to know, well, what is this new calculation? Well, we can go back to our old standard of, well, if we know the number of moles, 0.132 moles, and we know we have 160 milliliters, well, how many moles would we have if we had 1,000? That's how we'd find our new big M. Well, that's one way of doing it. An easier way of doing it, though, is say, okay, let's see. We don't know that. We now know this is 160. We know how many moles we poured in, and we know what the molarity is. So let's use something like this. I need a new sheet here. All right. So again, what do we know? We know a volume of the concentrate, so CONC. We know the volume is equal to that we poured in 110 milliliters. We know the molarity of that is 1.2 big M. And we know the dilution. What do we know about that? Well, we know the volume, or we'll call it V2, is 160 milliliters. And what we're trying to find is the M2, or the molarity of this dilution. So it's a fairly simple calculation. You take your molarity, you multiply it by your volume, and you set that equal to the molarity of the second times the volume of the second. So when we do the math on this one, 1.2 big M times, now it's probably just easier if we just make everything liters, so 0.110 liters. That's going to be equal to what we don't know is M2 times our 160, or 0.16 liters. So I'm going to get M2 by itself by dividing by both sides, 0.160 liters. I see our liters cancel out. So in essence, I'm multiplying 1.2 times our 0.11 and then dividing it by 0.16. And what I find, not surprisingly, is that it's going to be, since we diluted the 1.2 big M, it's got to be less than that number. And not surprisingly, it's 0.825 big M. So that's what our M2 ends up being. And if we would have done the math on this, it's pretty much the same thing. If we would have done the math on this one, would have given us that same thing, 0.825. So the reason why we're doing this is because the moles really matter. And if we think about what we were doing the other day with our magnesium nitrate and our potassium nitrate, we're going to use something very similar. And how similar is that going to be? Well, we're going to say, since we know, and I'll just draw what we had the other day. We were trying to find out the molarity of this, and we knew we had, I think it was 255. Let me do some different. We knew on one side we had some KNO3, and we knew we had about 255 milliliters of that, and we knew that the concentration of that, if I'm not mistaken, was, what do we know that was? Point, written down somewhere. Yeah. So if I'm not mistaken, it was 0.102 big M. And we didn't know the number of milliliters of this, but we did know that the molarity of it was going to have to be 0.278 big M. And we did know that we were pouring in some magnesium nitrate, and we didn't know how much we were going to pour in, so I'm just going to make that X. And we knew that the molarity of that, oh, by the way, that's 2, very important. We knew that the molarity of that was did know the molarity was 0.416 big M. So I'm going to box out some things. So we didn't know how much we were going to pour in. We did know the molarity of the magnesium nitrate. We did know the molarity of the potassium nitrate, and we also knew how much we poured in. We didn't know the total, but we did know the molarity. Well, we know the total now, right? We know that the total's got to be in there. It's got to be that 255 plus X. 255 milliliters plus whatever the X milliliters is. Right? So we can maybe think about this algebraically. We knew that the more concentrated one was a 2-to-1 relationship. So if we have 1 mole of magnesium nitrate, we would be doubling the number of nitrate moles. Right? So in thinking about this, I want us to now think about that M1V1 equals M2V2, because this is very similar, except instead of water, we're adding these over here, which I'm going to call M1, which now I'm going to call V1. I'm going to call V2, and this is going to be called M2, because this is going to be called V3, and finally this right here is going to be M3. And we say, well, these two make that. So how about we do the molarity of the first one times the volume, so V1. We're going to parentheses that because we're going to add that to the volume, big M of that, so M2 times volume of the second one, parentheses that. We're going to say that should equal the total that we get right in the middle there, which is we're calling M3 times our V3. All right, so we say this is additive. We add these two that have nitrates in them, and we should get our total volume and our total molarity because of that. We're going to use a little algebra here because we don't know some things. And the last thing is this. Since we know it's a 3-to-2, so if I know I have 0.416 moles of MgNO3, 2, right, I'm going to have double, or 0.832 moles of my NO3, right? So that's actually going to be my molarity of my M1 because of the 2-to-1 relationship. So I'm going to plug that number in. So 0.832 big M, which is moles over liters. Very important here. Right? So I can write moles over 1 liter. I'm going to multiply that times my X. So X. And that's going to be parentheses, and then my M2. Well, those are nice numbers. So I've got my 0.102 moles per liter. I'm going to multiply that by my volume of 255, which I'm just going to make it into liters. So my liters will cancel out there, and I'll just be left with moles. Very important. Then finally, this is where it gets a little tricky, and you have to use your algebra, and I hope I have enough room here. I'm going to say we have our M3, which is our 0.278. That's going to be moles per liter, and that's going to be multiplied by my volume, which is 255 milliliters. Ooh, I'm not going to have enough room. Plus my X. I have to multiply those through, meaning I am going to distribute. Right, so all this is together. All right, so when I distribute this, what do I get? Well, let's see. Why don't I multiply these two out? So again, I'm leaving that X there because X is going to give us an answer in liters. So I want to leave those liters there. So I'm going to multiply these two out. I'm going to write this over here, 0.3832. That's going to be moles per liter X. I'm going to say plus these two, the liters cancel out, which is nice. So I get 0.02295 moles. And I'm going to set that equal to, now this is where it gets a little tricky because I have to distribute. So I'm going to distribute first to the 255, and should make that 0.255, and that's liters. So when I multiply these two, I'm going to cancel out my liters and be left with 0.06255, and that's going to be moles. And then my next one is just going to be plus. I'm going to multiply the X, so it's going to be 0.278X, and that's going to be moles. Sorry, I'm going to squeeze that in. Moles per liter. So what I'm going to do here is I'm going to circle the two that are like, which are the ones that have the X in it. And then the other two, I'm going to do an orange. and I'm going to combine like terms. So I'm going to subtract this number from that number. When I do that, I get an answer of, oh, and I'm going to subtract this number since it's a little smaller from that number. So I'm going to just give you totals here. So when I subtract the 0.278 from the 0.832, I get 0.554 moles per liter X. And that's equal to, I'm going to subtract that 0.02295 from that 0.06255 number. And I'm going to get 0.0396. That's just going to be moles. Now I'm going to get X by itself. So I'm going to multiply by the reciprocal here. So I'm going to multiply by liters over 0.554 moles. So that these cross out. Will leave me with X. So my final answer will be there. But I'm going to do multiply over 1. So liters over whatever I do to one side, I do the other, which in essence I'm just multiplying by the reciprocal. So in this case, my moles cancel out, and I'm left with liters, which is great. And when I do the math on that, I'm going to get 0.0714 liters, which is 71.4, right? 71.4 milliliters. So I'm pouring 71.4 milliliters of my 0.416 in. I'm going to add 71.4 milliliters to my 255 to get my total, and then that's how I'm going to get a 0.278 molar solution if I pour a little bit of this potassium nitrate in. So there is my answer for X. Right. Hopefully that helps. That's what we did today.